Hello dear students, welcome back once again for the session that we were doing on the chapter atmospheric pressure. So today I hope the students of class 7 will pay attention as I continue the chapter which I started in the last class. So we were doing the atmospheric pressure in the last class. And we did the different pressure belts. We saw the equatorial low pressure belt, the subtropical high pressure belt, then the subpolar low pressure belt, and the polar high pressure belt. These were the different pressure belts we had discussed in the previous class. So today we continue with the chapter, and today we focus on the lesson that is winds. What are winds? Now, winds are the horizontal movement of air from a cold place to a warmer place. That means winds always blow horizontally straight this way, straight. The air going up and coming down, that is the vertical movement, and that is called as the air current. When the warm air rises up and when the cold air sinks, it is called as air current. But today we do the lesson on winds. So what is a wind? Wind is the horizontal movement of air from a high pressure area. Cold places always have high pressure. So they blow from a high pressure area to a low pressure area. And low pressure means a warmer place. So winds are the horizontal movement of air from a high pressure area to a low pressure area. Now, winds speed vary from place to place. Some areas the winds are stronger, some areas the winds are milder, some areas the winds are very destructive. Again, some areas there's practically very less winds. We saw that in the last class. See, as I was talking about the pressure belt. How does the doldrums practically have no winds? No winds at all in the doldrums. That's why they call us doldrums, the equatorial low pressure belt. From 0 degree to 5 degrees, they call us the doldrums because there's no winds. I even explained to you about the horse latitude in the subtropical high pressure belt where very less winds blow. See? So some areas the winds are very strong, some areas the winds are very, very mild, and in some areas there's practically very, very less winds blowing. So as I was saying, winds is the horizontal movement of air from a high pressure area to a low pressure area. Now, see, high pressure area to a low pressure area. Now, the winds is measured by an instrument called the wind vane. I would just like to show you this. See, this is the instrument that is used to measure the wind vane. It's called as the weathercock. This is the weathercock on top. This is the direction. Winds always point to the direction where it blows. So this arrow will always point to where the wind is blowing. So if it's facing this side, see, eastern side, that wind is blowing from east. So we have the north, south, east and west. So this instrument is called as the wind vane, or whether we call it as a weather sock. See, weathercock. This weathercock records the direction of the wind. We also have a wind vane. We also have a weather sock, which is used to show the direction of the wind. Okay, and then we also have an instrument here, which is called as the anemometer. It's called the anemometer, where, see, this is the anemometer. This records the speed of the wind. The first one I told you is the weathercock, which measures the direction of the wind, which shows us from where the wind is blowing. And this instrument is called the anemometer. It records the speed of the wind, how fast it blows. That is recorded by this anemometer. So now, coming to this lesson, wind direction is measured by a wind vane, weathercock, or a wind sock. Wind sock is basically practically found in the aerodromes, helipads, See, we have a cloth hanging in the air, tied to a long pole, and that cloth which constantly moves, which is in black and white stripe, sometimes it's also in red and blue check, that constantly blows in the air drums or in the helipads, that shows the direction of the wind. Now, the speed of the wind is measured by an anemometer. Now, there are different types of winds that blow around the world. The first one which we have is called the permanent winds. It's also called as the planetary winds. Permanent winds or the planetary winds. It's also called as the prevailing winds. It's also called as the prevailing winds. The first one, permanent winds or the planetary winds. It's also called as the prevailing winds. Now these are permanent winds. These blow in the same direction throughout the year. They don't change the direction. They blow constantly in the same direction throughout the year from December to January, again December to January. These permanent winds or the planetary winds blow in the same direction. They don't change the direction. They constantly blow in the same direction. For example, we have the trade winds. See? Then we have the westerlies. Then we also have the polar winds. These are the permanent winds which blow constantly in the same direction. They are the trade winds, they are the westerlies, and they are the polar winds. So I'll just explain to you about these winds. Here, see, last time we did this diagram. We had done this diagram last time. And this diagram explained to us about how the pressure is experienced in different areas. So here, see, we can look at this diagram and see here. See, the first one here. Here we have the okay, I'll just erase this out first. Okay, so that is HC. So I'm going to just write here. See, this is the 0 degrees. 0 degrees. It experienced the equatorial low pressure belt. This is the 30 degrees north, 30 degrees south. It's called as the subtropical high pressure belt. This is also called a subtropical high pressure belt. This is 60 degrees north, 60 degrees south. This is a subpolar low pressure belt. Subpolar low pressure belt. Here also we have the subpolar low pressure belt. And then we have here 90 degrees, that is the polar easterlies. Here also we have the polar easterlies. So these are the different areas. Equatorial low pressure belt, subtropical high pressure belt in the north and south, subpolar low pressure belt in the north and south, polar high pressure belt in the north and south. Now, how does the permanent winds or the planetary winds or the prevailing winds blow? See, they blow in the same direction throughout the year. The first one I just told you is the trade winds. See, they blow from 30 degrees north and 30 degrees south towards the equator. See, they come from the eastern direction. See, trade winds, they come from the sea, northeast and southeast. These are called the trade winds. These winds blow in the same direction throughout the year. They blow in the same direction throughout the year. And because the winds blow to the equator, the warm air gets warmed, it rises up, again it moves to the poles, it gets cold, it sinks down. When it sinks down, it creates a high pressure. See, this turns into high pressure. Here and here. Again from here, because the air is very cold, it moves to the warmer place. So again it comes to the equator. Again the air gets heated up, again it will rise up. So that is how we have the winds constantly blowing from the 30 degrees north and south towards the equator, which is called as the trade winds. And these winds blow in the same direction throughout the year. They will not change. The second one which we have is the westerlies, because they blow from the western side. See, this is called as in the northern hemisphere, it's called as the southwesterlies, and in the southern hemisphere, it's called as the northwesterlies, because they blow from the western side direction. This is the second permanent wind. See, the permanent wind, that is the westerlies. Same direction they blow throughout the year. Again, they will not change the direction. Now, these winds, the westerlies, bring up some amount of rainfall. In the northern hemisphere, they bring some rainfall to the western side of the continents. And the speed of the wind in the northern hemisphere is less compared to the wind that blows in the southern hemisphere. The westerlies that blows in the southern hemisphere has a greater speed. The reason why they blow with a greater speed is because of the absence of continents. There is more water in the southern hemisphere, because of which they are stronger, and that's why they give it different names like the roaring 40s. See? Then screaming 50s, screeching 60s, and so on. See? They give it different names. Roaring 40s is one name. Then they also give another name here. In the, see, furious 50s and screaming 60s. So these are the winds that blow from the 30 degrees north and 30 degrees south towards 60 degrees. That means they blow from the subtropical high pressure belt to the subpolar low pressure belt constantly. Because this is a low pressure, it's warmer. So from here also it will rise up, it moves to the poles and come to down, it sinks down, again this way. Constantly it rises up. Circulation of air takes place. Here also, from the 30 degrees south subtropical high pressure belt, they blow down to the subpolar low pressure belt. They blow down in the same direction throughout the year. And they don't change the direction. Constantly they blow. That is why they call as permanent winds or planetary winds, also prevailing winds. And these bring rainfall. And I told you the speed of the wind in the southern hemisphere is stronger compared to north. That is why they give different names like the roaring 40s, then furious 50s and screaming 60s. Then the last permanent wind which blows is the polar easterlies. It's called as polar easterlies. See, it blows from the poles. See, from the north pole it blows to the subtropical high pressure belt, 60 degrees north latitude. From north it goes down. See, these are called as polar easterlies. These are cold winds. That's why they come to the warmer areas. Here also, see from the southern part, they blow polar easterlies. See, southeast, they blow from southeast. They blow constantly to the 60 degrees south latitude, which is the subpolar low pressure belt. So constantly they blow in the same direction. And these are cold winds. And therefore these are the permanent winds that blow in the same direction throughout the year. The trade winds, which blow from subtropical high pressure belt towards the equator in the north and south. Then we have the westerlies, which blows from the subtropical high pressure belt to the polar low pressure belt in the north and subtropical high pressure belt to the subpolar low pressure belt in the south. And then we have the polar easterlies, which blow from the north 90 degrees, they blow towards the 60 degrees subpolar low pressure belt in the north, and also from the 90 degrees south they blow towards the 60 degrees south latitude. That is the subpolar low pressure belt constantly. So these are the polar winds that blow constantly in the same direction. So now let's see a little bit further. Let's go to the next page here. Now the second type of wind which we have is called the periodic winds. Now what are the periodic winds? Periodic winds are those winds which blow for a certain period. Like they blow in one direction for a certain time, and again they blow in the opposite reverse direction in the other time. That is called as periodic winds. The permanent winds are the ones which blow throughout the year in the same direction. But the periodic winds are those winds which blow in a particular direction for some time, and then they blow in the opposite direction for the other time. They are called as the periodic winds. The examples we have is land and sea breeze. See, land and sea breeze. And the other example we have is the monsoons. So these two are the examples of the periodic winds, land and sea breeze and the monsoons. So let's try to see if we have some diagrams here. Okay, so first let's just see the land and sea breeze. This is an example of the periodic winds, land and sea breeze. Okay? Yeah, let's see. Yeah, land and sea breeze. Now, how does the land and sea breeze take place? See, now, in the land and sea breeze case, the winds blow from the land to the sea during daytime and then from the sea to the land during nighttime. So it's a daily basis. But in terms of the monsoons, the wind will blow they will blow from a particular direction to the other direction for one season. For some time, they will blow from one place to another. And then for the other time, other remaining months, they will blow again in the opposite direction. That is in case of the monsoons. In case of the land and sea breeze, every day it takes place. Every day the winds goes on changing. But in case of monsoons, it changes according to the season. So in the first case, land and sea breeze. Now, the land breeze takes place during the daytime. See, during the daytime what happens? When the sun shines, the warm air starts to rise up. See, the warm air starts to rise up. You can see the warm air rising up here. See, warm air is rising up. As the warm air starts to rise up, what happens? This area experiences a low pressure. Because the land is very warm during daytime compared to the sea. Since the land is warmer than the sea during daytime, this warm air will start to rise up. And as this warm air starts to rise up, what happens? The cool air from the sea starts to come toward the land. See, they blow towards the land. You can see, because while the sea is colder, it has a high pressure. See, it has high pressure. The land is warmer, it has a low pressure, and because the land is warmer, the warm air will rise up. And as the warm air rises up during daytime, what happens? The air has to be filled. So the cool winds come from the sea to occupy the space. Whereby it's called as the what breeze? Sea breeze. Sea breeze. Again, this warm air will rise up. It goes to the sea. See, it goes to the sea. Again, after the sea, it gets cold. Again, it sinks down. It sinks down. Again, from the sea, it moves to the land. Constantly. This happens during daytime, which is called as the sea breeze. So we can see the land and sea breeze taking place here. The first one we have is the sea breeze taking place. And this sea breeze takes place during the daytime when the land is very warm and the sea cold. So winds from the sea will constantly blow to the land, which is called as the sea breeze. And that is why during the days when you go to the sea beaches, you feel very, very cool. The temperature is very moderate, not very hot and not very cold. It's because of the sea breeze, which makes the land cool. That is the sea breeze taking place. Then we also have the land breeze. Now this land breeze takes place during the night. Sorry. Okay, let's see. So what happens during the night time? During the night time, what happens is this opposite happens. Okay, so what happens during night time? During night time, what happens is that the land gets cooled faster than the sea. Because we know that the water takes a long time to get heated and it takes a long time to get cooled as well. So during daytime, the land is warmer and therefore winds blow from the sea to the land. But at night, what happens? The land will lose the heat very fast. And as the land loses the heat very fast, what happens? It gets cold. It experiences what? High pressure. The land will experience a high pressure. And the sea, being warmer during night time, will have a what pressure? Low pressure. See? During night time, it's the opposite. Land is cooled faster than the sea, therefore the air is very cold. And the sea is warmer compared to the land, and therefore they experience a low pressure. So what will happen? The air from the sea will start to, the warm air starts to rise up. From the sea, the warm air starts to rise up. The warm air from the sea starts to rise up. And as the warm air starts to rise up, cool winds from the land will move towards the sea. See? Cool winds, cold winds from the land will move to the sea, which is called as a land breeze. So as the warm air from the sea rises up, it moves to the land. See? And after it moves to the land, it gets very cold, and therefore it starts to sink down. After the air sinks down, again it gets cold, again it moves from the sea land to the sea. Constantly it happens during night time, which is called as a land breeze. So you just saw the difference. During daytime, the winds blow from the sea to the land, because the land is warmer and the sea is colder. But in night time, see, the opposite happens. See, the land is cool, the sea is warmer, so winds blow from the land to the sea during night, which is called as a land breeze. So this is how the land and sea breeze takes place. Okay. So now let's see the next part. Yeah, let's see the next one. The next one we have is the monsoons. Now this monsoon also is the same. See? Now if I just want to show you once again this diagram here. So we continue now with the next part of the periodic winds, and that is the monsoon winds. Now how does this monsoon winds take place? Now this monsoon winds, as I told you, also is an example of a periodic winds, because it blows in one direction for a particular season, and then again it reverses its direction. It comes back in the opposite direction for the other duration of time, for the other season. So that is why these are called as the periodic winds. The land breeze and sea breeze blows in one direction during daytime, night again comes back. But the monsoons takes place a longer time. It's not for 1 day or 2 days, it's for almost 3-4 months. So for a particular season, the monsoons will blow in one direction and then in the opposite direction for the remaining seasons. So that is the monsoons. So I'll just explain to you a little bit here. See, how does the monsoons take place? During summertime, the winds will blow from the sea to the land. See, they are blowing from the sea to the land. And as these winds blow from the sea to the land, they bring plenty of rainfall. And that is why the monsoons winds are so very important for us, because it brings a lot of rainfall to our country. And as we know that India is an agricultural country, so many people are dependent on the agriculture. See, therefore, the monsoon plays a very important role. And we have also, we have also known that the climate of India, as we say, is a tropical monsoon type of climate. So the climate that India experiences is called as the tropical monsoon type of climate. Why monsoons? Because the monsoons are very, very important for us. So here, as I was saying, the monsoons blow in one direction during the summertime. In the winter time, it comes back in the opposite direction. See? During the summertime, when it blows, it brings moisture from the sea to the land, giving plenty of rainfall during the month of June, July, August and September. And then in the remaining months, from remaining months, December onwards, what happens? The winds blow from the land to the sea. They blow from the land to the sea, in the opposite direction. So this is also an example of the periodic winds, that is the monsoons, because it blows from the sea to the land in one time, and then from the land to the sea in the opposite direction. Now let's go further. Now let's see the local winds. What are the local winds? Local winds are those winds which blow in a particular area, in a small area, for a short duration of time. They don't blow constantly throughout the year, and they don't blow in a large area. Local winds are those winds which blow in a particular area for a short duration of time. Maybe the wind takes place because of the particular shape of that land, a relief feature of the land, or maybe because it's closer to the sea and so on. This local winds takes place. The first one we have is the katabatic winds. You can look in your textbook and see katabatic winds. Now these winds blow from the mountains to the valleys. See, during daytime, the winds blow from the valley to the mountains. Nighttime, the wind blows from the mountains to the valleys. They are called as the katabatic winds. And the katabatic winds also, we have some examples. Like for instance, we have the cold winds. Example of cold wind which blows in a small area. Like for instance, we have Mistral, which blows in southern France. Then southerly busters, which blow in Australia. Bora, which blows in the Hungarian basin. Then we also have hot winds, which are also examples of local wind, which blow in a particular area, like the Chinook, which is a hot wind, which blows in Rocky Mountains. We have the Fohn, which blows in the Alps, which is also a hot mountain. And then we have the Cyclones, which blows in Southern California. So these are the examples of the local winds. See, the katabatic winds, which blows from the mountains to the valleys during the night time, and we also have winds which blow from the valley to the mountain during the daytime. Then we also have other local winds. The other local winds, for instance, if you see, we have is the Kal Baisakhi, which takes place in India, in West Bengal and Assam. This wind blows. Kal Baisakhi in the month of April and May. It's also called as the calamity of the month of Baisakhi, because during this month it causes a lot of destruction to the crops and property. It's called as Kal Baisakhi, which is also an example of a local wind. Then we also have Loo, which is a hot wind which blows in the great plain of India. See, in northern plains of India, the Loo, which is a very hot wind, which is also an example of a local wind. And then we have other winds as well. Like if we go to the southern part, we have the wind called as the mango showers. See? That also could be termed as a local wind because it blows for a short duration of time. So that is it. Now we move to the cyclones and anticyclones, which are variable winds. So we have done what are permanent winds. Permanent winds are those winds which blow in the same direction throughout the year. Example we have is the trade winds, the westerlies, and the polar winds. Then I told you we studied about the periodic winds, the winds which blow in a certain period in one direction and in the opposite direction for the remaining time. For example, the land and sea breeze. And then the monsoons, which blows from the sea to the land during summer and from land to the sea during the winter time. Periodic winds. Then we did the local winds just now, see. The katabatic winds. Examples I give you. The cold winds and the hot winds which blow in certain areas for a certain period of time. They don't blow throughout the year. In a specific period of time, for a specific duration, and in a certain area. And then other local winds like Baisakhi and Loo. So now we go with the cyclones and anticyclones, which are the examples of variable winds. So let's just see. Variable winds. Okay, let me just see if I can follow this. Yeah. The first one which we're going to do is the cyclone. Now cyclones basically take place in the seas where a certain area may be experiencing a low pressure. So when certain areas in the sea experience a low pressure in the center, what happens is the winds will start to blow out. The winds will start to blow out outwards. See, they blow outwards because the surroundings are colder and the central part is warm. It has a low pressure. The air is warm. So what happens? Since the air is warm, the warm air from the center will start to rise up. The warm air will start to rise up. And because I told you the surrounding is cold, having high pressure, they will move to the center. They move to the center to occupy the space. And when the warm air is pushed higher and higher up in the sky, condensation takes place. And then what happens? They start to fall down as rainfall with thundering and lightning and strong winds and very heavy rainfall takes place. That is in terms of the cyclone that takes place. So they blow anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. That is the cyclones. The anti-cyclones are slightly opposite. If you see, they are slightly in reverse. If you see, here. In the case of anti-cyclones, what happens? The low pressure is in the surrounding regions, and in the center they have a high pressure. See, in the center they have cold winds, but the surrounding of the sea have low pressure. They are warmer. Winds are warmer. The water is warmer. So winds from the center will blow out. They blow out to the surrounding areas. They blow out. And as these winds blow out of the center, they are dry winds, and therefore they don't bring any rainfall. They don't have any moisture because they are dry. But in case of cyclones, the winds are blowing. See, they are in the center. The low pressure is in the center, and as they go up, as the warm air is pushed up, what happens? They are condensed. The warm air pushes higher and higher, and then condensation takes place. Clouds are formed, and then it starts to rain. In case of cyclones, but in anti-cyclones, what happens? See, in the center we have a high pressure, but the surrounding has low pressure. That means the air is cold in the center, and the surrounding is warm. So winds blow from the center outwards, which have no rainfall, and they are very, very dry as well. And during this time, the sky is also very clear and sunny as well, because they don't bring much amount of rainfall. So these are the examples of the the variable winds, the cyclones and the anti-cyclones. Now let's go a little bit further and see what we have done. Okay, now let's go to the book and let's go a little further and let's see what is humidity. What is humidity? Now basically, if you see, humidity is the amount of water vapor present in the air. What is humidity? Humidity is the amount of water vapor present in the air. Okay, students, we move further ahead, and now we come to the humidity section. What is humidity? Humidity is the amount of water vapor present in the air. Once again, I would like to tell you, humidity is the amount of water vapor present in the air. How much water is there in the air? That is termed as humidity. When I ask someone, what is the humidity of a particular place? You will try to measure or calculate how much water is there in the air, and accordingly tell. So humidity is the amount of water vapor present in the air. Now this humidity will vary from place to place. It's not the same. Some areas the humidity is higher, and more the humidity, the more the rainfall, lesser the humidity, lesser the rainfall. So it goes on varying. That means more the water vapor in the air, there is more chances of rainfall. If there's no humidity at all, there's no chance. There's going to be very less chance of rainfall. That is why when we measure humidity, we will be able to know whether we are going to have rainfall or not. That is why measuring humidity is so very important. It will tell us whether we are going to have rainfall or not. It is a part of weather forecast as well, measuring humidity. Now, humidity is measured by an instrument called the hygrometer. It's a small device. You can keep it at your rooms or in the school. We have in our school as well. Humidity is measured by an instrument called the hygrometer. And then we also have our instrument called the which also measures the humidity. A wet and dry bulb thermometer. So these are the two instruments which are used to measure the humidity. Now the scales that are used in measuring humidity are grams per cubic meters. Humidity is measured in grams per cubic meters, especially when we measure absolute humidity. And when we measure relative humidity, we measure in percentage. Okay, so when we measure relative humidity, we measure in percentage. So here, now we have two ways of measuring. One is the absolute humidity and the other one is the relative humidity. Humidity can be measured in two ways. One is the absolute humidity and the other one is the relative humidity. So what is an absolute humidity? Absolute humidity is the amount of water vapor present in the air at a particular time and place. Once again, I would like to say, an absolute humidity is the amount of water vapor present in the air at a particular time and place. But whereas it is measured, I told you with the scale grams per cubic meters, but whereas the relative humidity, what is a relative humidity? Relative humidity is the ratio, it is the difference. Relative humidity is the difference between the amount of water vapor present in the air and the actual amount of water vapor the air can hold at that temperature. The difference between how much water is there in the sky and how much water in total the sky can hold, that is called as the relative humidity. Difference in the amount of water vapor present in the air and the actual amount of water vapor the air can hold at that temperature. Suppose at that temperature air can hold 100% water. But if only 50 is present, if only 50% of the water is there in the atmosphere, so this difference of 50 and 100 is called as the relative humidity. The difference between the amount of water vapor present in the air and the actual amount of water vapor the air can hold at that temperature is called as relative humidity. So please keep that in mind. Now we have a word there in your textbook called as the saturated air. What does saturated air mean? Saturated air means when the humidity is 100% and when the air can hold no more water vapor, we say that the air is saturated. The air is full of water now. And any time you will have rainfall, that is called as a saturated air. Then we have another term called as dew point. See, the temperature at which the air is saturated and cannot hold any more water vapor is called as dew point temperature. So the temperature at which the air cannot hold any more water vapor, whereby it gets saturated or whereby it gets condensed and forms into droplets of water. So dew point is the temperature at which they can hold no more water vapor. Okay? It's called as a dew point temperature. So basically dews are formed in the early morning as the wind blows, and if the warm wind comes in contact with the cold surface, condensation takes place and that vapor is turned into droplets of water, and that is how dews are formed. In the cold places, that is termed as frost. Because of the very cold temperature, it turns into ice crystals, frost. Then, evaporation. What is evaporation? Very simple. See, you have been learning this from a very small class. It is when water evaporates from the oceans or from any water bodies because of the high temperature. When the water evaporates and changes from liquid to gas or liquid to vapor, it is called as evaporation. And as this water goes higher and higher in the sky, after some time it goes very high in the sky, and then what happens? Because of the cold temperature, condensation takes place. When the warm air goes very high in the sky, and afterwards it gets very cold, because of the cold temperature, condensation takes place. What is condensation? Condensation is the change of vapor into droplets of water. When gas is turned into droplets of water, it is called as condensation. Then we have different types of precipitation. See, like for instance, rainfall is an example of precipitation. Hailstone is an example of precipitation. Sleet is an example of precipitation. Snowfall is an example of precipitation. So when water is released from the clouds in different forms, it is called as precipitation. So now let's see the different types of precipitation or different types of rainfall we have. The different types of rainfall that we have are the convectional rainfall, the relief rainfall, and the cyclonic rainfall. See, convectional rainfall, the relief rainfall, and the cyclonic rainfall. So in the first case, in the case of convectional rainfall, what happens? Because of the high temperature, the land gets heated up, or even the water body gets heated up. So when that water starts rising up, see, when the warm air from the land starts to rise up and goes higher and higher in the land, condensation takes place. And because of the cold temperature, what happens? Condensation takes place, and then from there itself, water starts to fall down. After clouds are formed, water is released in the same place. That is called as convectional rainfall. It's also called as 4 o'clock rainfall because most of the time it takes place in the afternoons. Because of the high temperature, the warm air rises up, and as the warm air goes higher and higher up, condensation takes place, clouds are formed, and these clouds release the water down in the same area, whereby we have what is called as a convectional rainfall. Now, in a very simple term, the next one we have is a relief rainfall. What is a relief rainfall? When the warm water from the seas and oceans, water bodies, when they evaporate, the water goes higher and higher in the sky. Because of the cold temperature, condensation takes place, droplets of water are formed. These droplets of water will mix with the dust particles, the smoke particles, and so on, and they start to form into clouds. And as they form into clouds, they move towards the land. And when these clouds come towards the land, and if there is a barrier, there is a mountain on the way of the clouds, what happens? The clouds cannot go any further, and thereby the release all the water in the form of rainfall or snowfall. This is called as a relief rainfall. When the rainfall takes place because of the barrier caused by a mountain, when the mountain or a hill blocks the winds, whereby forcing the clouds to release all its rainfall, it is called as a relief rainfall. So this side of the mountain is called as the windward side. This is the area where they get maximum rainfall. And after the clouds have released all the rainfall, it crosses the mountains which are practically dry, and then various rainfall takes place in the leeward side. It's also called as the rain shadow area. So this is how the relief rainfall takes place in a very simple way. And then we have the last one, that is the cyclonic rainfall. I've explained to you how cyclonic rainfall takes place. Because of the warm area in a particular area, what happens? The air is pushed up. And when the air is pushed up, cold winds from the surrounding areas come to the center. The stronger the winds coming to the center, the more the air is pushed up, the warm air is pushed up. And after some time, when the warm air is pushed up very high, what happens? Condensation takes place, and then the clouds are formed, whereby releasing all its rainfall, which is called as a cyclonic rainfall. Okay, so please keep in mind there are 2 types of cyclonic rainfall as well. We have the temperate cyclonic rainfall as well as we have the tropical cyclonic rainfall. Okay, the temperate cyclonic rainfall have lighter rainfall compared to the tropical cyclonic rainfall. But then the temperate cyclonic rainfall, these cyclonic rainfalls, what happens is do not last for a longer time. The temperate cyclones last for a longer time. See. Whereas the tropical cyclones give a lot of rainfall, but they last for a short duration of time. So these are the different types of rainfall that we have: the relief rainfall, the convectional rainfall, and the cyclonic rainfall. So this much for today's lesson, dear students. Whatever questions are there at the back of the chapter, please make sure you do it, and read the chapter as well, and do the assignments at the back. You can turn your books at the back and see the assignment A, B, C, and D. Please do A, B, C, and D without faith. Make sure you do all the questions. And if there's any problems, you can just mark the questions, and later on when you come to class, we'll discuss and solve the answers. Okay? Thank you so much. Have a good day.